Hello, this is Steve Proud, and today we're going to talk about CMMO-ST-LKP. And we're going to be using a Rockwell PLC network card for Ethernet IP, and we're going to communicate to a point IO at 1734 AENTR, which has a IO-Link master, as you see here, and we're going to be talking again to the CMMO-ST. Now, Festo has function blocks for the Rockwell PLC, the ControlLogix series, compact ControlLogix. And when you type in the part number on the website and the support portal, select LKP. And under technical documentation, we have Festo has a manual, this one right here, which discusses the FHPP profile. And on the software tab, scroll down here, you have this support library for it's version 2.2 is the latest one, which is what we're using today, and it's for this various controllers here. CMMO-ST-LKP is one of them. So if you download this and install this library into your Rockwell PLC, you will have these add-on instructions right here. Okay. I'm not going to show you today in any detail on how to install these. I hope if you're a Rockwell programmer, you know how to do this yourself. I just want to get to the point on how to use this, because the library comes with a user manual and discusses a variety of function blocks that are in the library, and sometimes it's not very clear to the user how to use them. So the FHPP library, I've modified this right here a little bit. The library itself is this right here. This is the version I'm using. If I don't have my own tabs, then you end up with this menu system over here. So this describes the whole device profile and what its purpose is and how to use it. If you go through, it shows you that the first 8 bytes are what the functionality is, and so it's a force. So again, this is not a detailed video. This is just to get to the point. With the Festo Configuration Tool, you basically create a project using a CMMO-ST. You select the LKP, pick your motor and drive. This particular point, I'm just using a rotary. Make sure that you have IO-Link and not iPort or Modbus. So it's IO-Link. Whatever you need here, you select. Homing method. And I'm just going to jump forward to the field bus settings. So in order to use the full functionality of the Festo handling positioning profile, you need to also select the plus FPC. If you don't have the plus FPC, then certain function blocks, which are called FPC function blocks, Festo parameter channel, do not function. So you have to make sure that this is selected as shown here. Factor group is not selectable like some other controllers we have, or Festo has. The default values for record mode, direct mode, these are values here that are used over the FHPP plus, or not plus, FHPP. And you do a download of the controller properties once you've finished, and you do a store, and now upon cycle power, you're ready to roll. When it comes to the Rockwell world, this particular code I have here is very basic. You have your Ethernet card here from a hardware standpoint. My hardware is configured like this. Nothing of any great detail. There's networks. There's my IP address, port configuration. We're not using a linear or device level ring network. We're just using a typical linear. You then have to add your point IO card, which again I'm not going to go through, but it's well, you would basically come through here, select your card, this one here, add it. It's configured like so. Disable keying, rack optimization, chassis size, normal standard things. Basically used unicast, give it an RPI. Cancel, and then you have to add the IO-Link master, same method, right click, new module. Double click on this. Make sure that your connection is set up like this. Use unicast again, RPI, and you would right click, either register the IODD file, which is again on the Festo website. Scroll down here, parameter files, IODD file. So this is the IODD file here. So you add the device and put it on whatever channel you have it connected to, and at that point you're basically configured, and you have your CMMO added to your project. That creates tags, of course. I've used a couple of the tags in the project. You know, I'm making sure that I've got some typical status bits here. I'm monitoring the link on the card to make sure we're up and running, and then I'm monitoring the IO-Link master, which is the port right there. Make sure we're not faulted on that. Then it creates tags. You have the point IO inputs and outputs. And you have the data. So because of our configuration, we've got 16 bytes, which is the FHPP plus the FPC. Each one of those represents 8 bytes. As you see here, there's 16 bytes. And in my project, like I said earlier, I'm using I'm monitoring the status of the communications to make sure we're up and running, everything's connected and working, and then you start to add your function blocks within the library. Now I've got a little bit of code here, it's very stripped down. The basic minimums for anything within the library is you have FML read. This here is a configuration so that you set up the data that you're reading from the controller through the IO-Link. You'll see here that the point IO channel data, you specify the starting address. So this right here, starting address for FHPP in is byte 0. The FPC in is byte 8, as we just showed. That is input data. So we're starting here with the FHPP, and we're starting here for the FHPP or the FPC channel. And you have to configure a device type. If you read the manuals, it's as I've written here in my description text, my run comment, the CMMO-ST is 10. That represents that particular device. If you pick the wrong device, then it won't work. That's the whole purpose. And the Modbus and high byte first, if you read the manual, the IO-Link Modbus is equal to 0 and high byte first is equal to 1. So that's why this is configured as it is. The CFG FPC represents the fact that you are using the FPC channel. and then the read is set up. And likewise, the very last thing in your code should be the FML write, so that you read your inputs and then you write your outputs. Same concept. You've got the FML ref, which is the same data structure for all of them. That's what shares the data from the FML read and write to the other function blocks. You select your channel. Again, this is the output channel. Starting address is 0, like shown previously. The FPC out starts at byte 8, and at that point you're getting data from the controller. You're not doing anything with it, but you're processing it. So the next function block, which is called FHPP control, which is this one right here, you have the ability to control the access. You know, standard things right here. You've got fault reset, you've got feedback of position, and so forth. You have to read the manual for the details on each one of these, but it's not something that I can just go into detail with. So basically, the OPM operation mode that sets up the mode of operation. I've described up here from the user manual that comes with the library that if this is set to 0 like it is right now, you're in record mode. If you change this to a 1, you're now in direct mode. And when you go online with the controller, with the FCT software from Festo, you have a FHPP monitor. This shows you the bits going to and from the PLC. So the answer to the PLC. So take the enabled and operation enabled. If you go to the Logix designer right now, you have the drive enabled, you have the load voltage applied, motion complete. That all matches to the this right here. So the motion complete, the acknowledge, the halts, things like that. If I come in here, for example, and I turn off the stop bit, the stop bit's off right here. Turn it back on, and the stop bit's on. Okay, so you can watch the data going back and forth. If you want to execute a move, you of course, and I'm just going to toggle bits right here for the sake of showing the user. So if you want to execute a home, execute the home, you get the acknowledge start, homing's valid. Turn off the home bit. I have one record move set up in this table here. So if I want to execute that record, I'm in operation mode 0, which is right here, and turn on start task. The axis starts moving. You get the actual position feedback through the FHPP channel. You can go monitor. Notice I have the FCT turned off, so I'm just in monitor mode. So it's actually executing. You have the target position, which is revs, and away we go. So I'm going to stop that move just for the sake of it. So it's now stopped. Turn it back on. So this here is how you control the drive. And if you go to the function block, you can use these tags. I've nested this into my own data type. You don't have to do that. You can use your own, but basically you have all these bits, which is one of the main reasons for the function block. You have all these bits which match up to the FHPP structure, and you would use that code, these bits, to program that particular axis. The next function block that we'll discuss here, again, this FPC here is this bit right here, so only if this is on are we able to actually use these. That's why all these are called FPC underscore and then the purpose. So You have FPC data object, FPC diagnostics, direct MP, file array, multi, and PNU. So this is the PNU. So in the user manual, you have a variety of what they call PNUs, which are the parameters. And you can gain access to read and write depending on the actual PNU itself to modify parameters that are in this FCT project here. The idea here is that when you're searching through the manual, if you have found something that's of interest to you and you want to read something, you have a PNU and you have a subindex. So if I wanted to read device fault, in my Logix code, I put in the 2051, so change this to 205, subindex is 1. I'm not going to write to it, I'm just going to read it, put a 1 in here, and gives you done, tells you that the actual PNU you requested, gives you a response back, and then gives you the value of that particular parameter. When it comes to the PNUs, you can only have one PNU active at one point in time. So if I came down here right now and I said, okay, execute this, it should not work because you have a active PNU already up here. So I'll turn this back off, turn this one off, come down here, put a 1 in, and now you get a done bit. The message number at this time, I'm taking this right here, the message number, and the hex value is currently 0. I don't have any faults. So first order of operations is only one FPC function block can be active at any point in time. So if it doesn't work, that's probably because you have a PNU that's active. If I turn this on and I try and execute this one, it doesn't work. So if you go to the PNU status, you'll get a status ID 10, and if you read the structure information within the manuals, you'll see that that 10 probably represents the fact that, hey, other FPC function blocks are active. So turn this back off, turn this one off. So PNUs, if you have access to a PNU, it'll be listed in the manual here. There's a variety of subindexes typically for each one, so you really have to read and understand. Some are read-only, some are write-only. Need to have the manual open in order to understand what those PNUs are. The FPC diagnostics, in short, diag, it just simply reads faults, okay? This one right here is another important one. So when you're in direct mode, again, I'm not going to go into detail what that is, but when you're in direct mode, the channel right here in the FCT has a base value of velocity, because when you're in direct mode, you send a percentage, a 0 to 100 percentage, and that represents 0 to 100% of this value here. You have an accel and decel, which are constants when you execute a move, and when you're in direct mode, you basically specify a target position, a velocity, and turn the start bit and executes that. So if you want to change your acceleration, your deceleration, or your base velocity, you can use this particular function block here. And right now, I'll just do a read. The actual velocity is this right here. If you look at the values here, we have actual velocity. Let's do an upload here. See. Oh, this is RPMs. So the mismatch here in what I'm showing you in the PLC, and what I'm here is because I have a project that's not really the right project. So let me just see what else I have here. Motor only. Let's try this one here, open. Okay. Go online. Download. Yes, yes. Store, yes. You have to turn off the FCT. So if I go back to my Logix now, the connection should have been reestablished. I'm just going to go back here and home it again. Did I lose a connection here? Hang on, I need to gain the control sovereignty back here. So 0, 1, now we're back active again. Start homing. Homing was executed. We're at 0. Record table. Okay, so for the sake of the fact that I had the wrong project open here, I'll just execute another record real quick. So I'm going to record number 2 and start task. And because of the scaling factor, the exponent, so field bus factor group, these are your units that are coming across, and told it to go to record number 2, which is 10 millimeters. It went to 2 millimeters, and in Logix, you have a whole number, it's integer, so you're getting 10,000, but it's actually 10.000 millimeters. And if I go back down where we left off to the direct MP, if I re-execute this now, so I have actual velocity is 200,000. So I have 200.000 millimeters. And this is 0.4 meters per second squared. And we get the proper units. So if you wanted to, I'm just going to change this here just so. So I'm going to turn this off. I'm going to execute a write next time. Turn this on. It's now written. Come over here. I do an upload. And we've changed the values here. Come back here. Turn this off. Make this 3. Make this, let's just put a 0 on it. Do a write. Go to FCT. Do an upload. And 300 milliseconds, 3 meters per second squared now. So that's the purpose of the direct mode, is to modify parameters. So I'm just going to turn this off right now. The next function block is called FPC multi, and this is where you can send multiple parameters. A really easy to understand situation with that would be to write to the record table, a couple recipes. You want to change part shapes or something on a machine. You want different recipes that you're using in the record table. You would execute this. So I have the source, destination. So within the structure of each of these arrays, you have PNU, subindex, access, which is read or write. This specifies what you're actually doing when it's executing that thing. So that's the PNU number, 4041. So if I go to the manual here, so 4041. So set point value, reading and writing our target position itself, and you have 1 through 64 for the subindex. That's the physical record number. Okay. And in this case here, access 1 is a write. So there's that recipe there, and the next recipe, 5100. So right now I have 5000. So if I come into my logics here, I'm going to write the second one here. It's going to toggle this bit. It's going to store the parameters that I'm using up top here. So that there is this right here. So I'll turn this off now. If I execute a 1, it's going to scroll through them all, give you a done. And if I come here and do an upload, see we've got 5, 10, 15, do an upload, and it's 5.1, 11, 16, 21. So I'm sending multiple records at the same time. It's just a contiguous write. Toggle this bit. Now I'm going to put them back. If I go back to the recipe that I just said there, so I'm putting a 5000 back in the first record, a 10,000 back in that record. So if I now do another write, scroll through until it's finished, turn it off, go to the FCT, do an upload, and these values here are all back to the whole numbers without decimals. So that's the FPC multi, and you can follow the manual to figure out the limitations of that. Then you have this key user point here. This is a way of storing the entire project that you have configured in FCT into your PLC, so that when you do a change out, maybe you've got a problem with your drive, you basically come into here and you can write all the parameters without using FCT. So I come into here, type a 1 in, and there's actually 21,948 bytes, and this is EthIP going down to IO-Link, so it'll take a little bit of time. Sometimes it takes about 2-3 minutes. And right now I'm reading every single parameter, meaning, this is a parameter, that's a parameter, everything, this is a parameter, these are all parameters. Every single thing that's in this controller, it's being read right now, and it's shoving it into a file array. So if I go up to here, monitor, this is a 25,000 byte array, and it's populating the values of each parameter. What those parameters are is irrelevant, because it's taking a snapshot of the entire configuration that you've made. So it's going to continue to work. And when it's completely finished, then you'll get a done bit. I'll let that continue. So like I said, right now it's taking all the data from here through IO-Link, EthIP back to the card here and into our project. That's basically what's happening. And what else can I show you here? Well, I guess I'll just let it continue. So it's almost finished here. When it gets up to the 21,948, you should get it done. If you stop this in the middle of its process, likely you'll get a fault, and you'll need to cycle the controller again, because it changes some things in the controller. So you have a done bit, you know it's finished. And if you want to do it right, you would simply do this and then execute again, and it will download everything. So if you have a new CMMO-ST and you've just installed it, set an IP address, you have a connection, then you can download all the parameters to it. And that is our shortest possible video on how to use the function blocks, which are this library right here, function blocks. I don't have much time to go into the detail of everything, but if you read the manual, as shown previously, this manual right here, download this manual here, it explains everything, and I hope this helps you in some way.